Today we're going to investigate some basic geometric definitions. So let's start with the word geometry. Prefix geo simply stands for earth, as most of you will know or already know. And metry, let's use the word measurement. So earth measurements. Now most of you may already know or think you know the definitions to the following, but let's just review quickly. So let's start with a point. Only location, no size. And we usually represent a point by simply putting a point and using a capital letter to name that point. So dot P, or I should say point P. Now we have a line, which can be defined as a straight continuous arrangement of an infinite number of points. Usually you will ask the question, how do I get from point A to point B, or what is that shortest distance? And we would say, well, that is a straight line. So there you have it. 2 points on the line with a line symbol above them gives us the name of that line, which would be line AB. Plane is up next. Had to adjust my chalkboard here as we didn't have enough room on the previous page. So plane, no thickness, just length and width would be the definition as I slide it up there. Another way you can think of this is if you had a coordinate axis, y, x, that would be two-dimensional, and we say a plane exists in 2 dimensions. And it would be represented by a cursive letter. My cursive isn't great, but cursive letter P. So if we simply drew like a piece of paper, and we labeled that P, that would be referred to as plane P. The word collinear may be slightly more difficult, but it simply means points along the same line. So let me slide the definition up. And an example would be if I had, let's say, 1, 2, 3 points like that, and connected a line between them, points A, points B, and point C are collinear. Next we have the geometric word coplanar, which, judging by collinear, I think you can guess what this means. This means that these are points on the same plane. So let's jam that definition in right there, and we can draw an example. We have a plane like this. Let's call this plane T. My cursive again isn't great. And if I put in point A, point B, and point C within that plane, those 3 points are coplanar. Next up, line segment. So the definition here is a little fancier. It's 2 endpoints and all points in between that are collinear with the endpoints. In other words, if we took point A and point B and connected the two, that would be referred to as a segment. So segment doesn't go to infinity. Segment simply stops at its endpoints A and B, and all the points in between that are collinear. And we represent that with the letter A, B, and a line symbol above that. So that would be segment AB. We can now look at the midpoint, which is defined as a point on a segment that is equidistant, fancy word there, from both endpoints. And equidistant simply means that if we are at point A, and we have point B over here, we can choose point M. In between is the midpoint. So the distance from A to M, represented by a slash mark, is the same as the distance from M to B. So 2 definitions there, equidistant and then midpoint, but the midpoint for this segment would be M. So now I bet you can give me the definition of congruent segments. Think about that for just a sec. Did you get it? Well, here we go. Let's slide it right in here. Two segments with the same measure or length would be considered congruent, and let me just draw it out here. So if we do segment, well, let me get my little pen going. There we go. A, and then B. We've got our line segment AB, which is represented by AB with a little line over it. And then let's do CD here. Here's my point C and my point D. I'm eyeballing it here, again, represented by CD. And this is the congruency symbol. It goes equal, equal, and a little tilde on top. So we have AB is congruent to segment CD. So now we have Ray, and no, not short for Raymond. Think about this one for just a sec. So here comes the definition of a ray, a geometric definition. So it begins at a point and extends infinitely in one direction. There you go. So if I took point A, and I started at that point, and I went out in one direction and added my arrow to it here, maybe put a collinear point there, B, in between, that would be ray AB, represented by AB, and then above that, a little, another little ray, just like that. So that's ray AB. So here we have it, a common end point of two rays is a vertex. So again, it is a point where two rays meet, and we can sketch it out as such. Again, let's say we have point A, and we extend this ray in one direction here, and then in another direction we have the vertex being right at point A. Incidentally, we've also created our next definition. Think about that for a second. That's right, we've created an angle being the intersection of two rays. Or another way to define angle is it is created by two rays sharing a common vertex. And let me just slide that definition right in here, just like that. So again, it's where the two rays intersect. They share a common vertex, and we can draw the angle like we did above, or we can just refer to it above. Oops, not to do this. So we've created our angle, and I could label this DAC. So we would have angle DAC created by these two rays, ray AD and ray AC, sharing the common vertex, which is point A. We've now arrived at the try these section of this screencast, so I'm going to put a couple of examples up here. You already see one. In fact, there we go. First one is this, what appears to be a segment, but I actually want to make it a line. So I am going to add some arrows onto the end here, which I was told I could do by Mr. Gagnon, and it looks like I can't. So I will do it like that. So understand that this isn't a line segment, that this in fact is a line. But based on how you label it, you could create a line segment out of it too. So take a look at this. I'm going to take a break from talking for a second and see if you can name a line segment, and a ray. And I would like you to use the proper notation. All right, so hopefully you turned off the screencast or pause it for a second. So here we go. Let's, so line, we could choose line AC. We could choose ray CB, and we could choose line segment AB. Now there are a number of different answers to this problem, but these are three that I've come up with, and hopefully you came up with a few on your own. All right, now I want to look at example 2. You have points D and E, and I'd like you to represent them from a collinear standpoint and a coplanar standpoint. Give it a shot. Turn the screencast off for a second and give it a shot. All right, so here we have D, and I will use my trusty writing utensil here. D and E, if I simply put the line through it, the way we have it right here, they would be collinear. Given the box that they're already in, actually, let me erase that. Go back to this box right here. If we simply just had point D and point E within that box, they would be coplanar. And these are collinear. All right, good work. Example 3, I'm just going to draw out for you. I'd like you to name as many angles as you can given this figure. Label that Y. We'll label this vertex X. And we'll label this point Z. You should know that we have ray XY and ray XZ that have formed angle. Well, I'm not going to give that to you because you're to find these angles. So let me extend one more ray out from vertex X and call this T. So, and then I will label this as angle 1 and this as angle 2. So your task is to give me all the angles within this figure. All right, well, it looks like there are 3 angles here. Hopefully you did pause the screencast and then go right to the answer. So the first would be, if we're looking at this 2, angle 2, we could label angle 2 as YXT. Look at angle 1 right here, and we could label that as TXZ. You always want the vertex as is your pivotal point in each one of these. And then finally, you may not have been able to see this, but there's a larger angle here, which you'll learn later. It's obtuse, and we could label that as angle YXZ. Incidentally, you can also go in the reverse direction. So for this one right here, we could label it as angle TXY. For this one right here, we could label it as angle ZXT. And for this angle right here, we could label it as angle ZXY. Notice that in all of these, the vertex never changes. It is always at point X. Thank you for spending a little time with me on this screencast. Hopefully you learned a little bit from it, and you can take these basic geometric definitions and apply them later on. Take care and have a great day.